Right, and get the agenda open. Okay, hi everyone. As you all know, this meeting is recorded and will be uploaded to YouTube. We have 3 items on the agenda today. The first one is descheduler label and namespace filtering. Not sure who would like to discuss this. There's no name.
Oh yeah, sorry. Hey, this is Sean.
Yep.
Can you hear me?
Yep.
So yeah, I'd added this to the agenda. So about 2-ish weeks ago, I had shared out a proposal document, a Google Doc with the details on adding two separate features to the descheduler. One is basically filtering pods that will be candidates for eviction based on namespace. Another one on label. So that's the high level concept. I'm not sure. Do we want to go through the doc, or I'm not exactly sure what the process is. I guess it's the first one I've submitted.
I think I'll leave that to descheduler leads. I'm not sure if we have any one of them here. Mike, do you want to speak to that, or?
Sure. Yeah.
There's so much noise on your line. I don't know.
Is there?
We can't hear you properly. I see Ravi as well. Ravi, do you wanna?
Can you guys hear me?
Yeah, we can hear you, but Mike, we can't hear you properly.
Oh, okay. So let's wait for Mike. I think Mike has some ideas that he wanted to share. So
okay. Let's move on to the second item on the agenda until Mike is back. Is that okay?
Let's do that till Mike is back.
Sure, I can go. So this is a PR that I sent out to upstream in place pod vertical scaling feature that now allows the pods resources to be mutable. And the reason to do this is that we want to resize pods without restarting them. And the code as it currently is mainly a contract. The changes are a contract between the API server and the kubelet, the node agent. And the user expresses the new desired node resources. In this case, the user would be typically VPA, which monitors what the right sizing should be and then updates, does a patch to the pod spec. And that is the kubelet watch sees that, and then it implements and the new resources, gives it the requests if there is node capacity available, or waits until it is available. Now, this introduces a new field to the pod spec called resources allocated. And the change here, and in many places, is to essentially have scheduler and other places where they were looking at requests, start using resources allocated, which is the true allocation on a node. So it's a one-file change as far as the scheduler is concerned, and I wanted to see if you had a chance to review this code. I can pull it up.
Yeah, I did take a quick look at the PR. It's quite massive, and I have a couple of questions, and then I'll leave it to the others if anyone else
Sure.
is. So the only mutable field here is that new field, like the resources allocated, right?
It's both of them. So there is limitation. The resources, previously resources was not mutable, and now resources becomes mutable, and the user can change this. That's the idea. Resources allocated is a new field that's got introduced to the pod spec. That is mutable only by the kubelet, yes. So there is admission control plugin which ensures that only nodes can change this, users cannot. And also there is a change to the node restriction plugin to ensure that node's only writing to this particular field and nothing else, that something is not allowed to do. So with those checks in place, this should be only written to by the kubelet. So and
let's focus on the scheduler part. And so the resources allocated, this is actually the amount of resources reserved on the node for that pod, right?
Correct.
And this is what we have to take into account when we calculate how much resources has been allocated on the node in general, like how much is allocated and how much is free when
right.
scheduling. Okay, so the change that you made, I think it makes sense. This is the only place where we have to take resources allocation into account in the scheduler, which is when we calculate how much resources allocated in the node info.
Is it okay if I shared my screen?
Yeah.
Okay, let me just do this. Desktop. Okay, so yeah, of all the, when I changed files in the scheduler, it did come across as, I found it a little strange that this is the only place in the scheduler that I have to change. There is another places where requests is being looked at. That's when the scheduler determines the fit for the pod's sizing. And in that case, it's okay for a new pod, a pod that's not bound, for the scheduler to look at requests and then use that to make the determination of where the node fits, run the predicates. So I did not make a change in that other place. So this was the only change that I made, because this one is well known that, okay, the node is looking at what the current requests what's currently used. And this was the only place I had it.
Right.
So you feel that this is the only place?
Right. Yeah, this is the right place to factor in your changes into what is being allocated on the node. So the other question is, like, the resources.request is still the field that we should look at when we make placement decisions for the pod, right?
Yes.
Not the because resource allocated is what is actually being allocated by the kubelet and it's updated by the kubelet, not what the user is actually requesting, because those could differ, right? And there's like a point where requests could be higher or lower than resources allocated, and kubelet is trying to drive the resources allocated to what requests is, right?
Right.
Okay. Yeah, I think that makes sense. I don't know if others, Aldo, if Wei is on the line, or Mike, have any.
I have a couple questions.
Sure.
So, is it accounted that some pods might be old, so they don't have this new field, or they don't have it filled up, or is there a migration process for that?
So if the resources allocated field, we handle that case for down level clients. So when you mean that pod spec doesn't have
right.
you mean YAML doesn't have this field?
When you upgrade a cluster, an existing cluster, and you have running pods,
yeah,
what happens to those pods, so that, because they need the new field, right? Is there a process that fills this field up?
yes. So in the plugin, what we do is, if I have to understand, to fully answer your question, I think I need to go back and understand how the upgrade process works, what exactly happens to the pod. And, but if you have a summary of this, it could help me. What I can explain is, currently what we're doing is, when a down level, let's say a kubectl client reads the pod does a get, and it doesn't understand this new field. So, and that's fine because the field is not shown, it drops it. And
Yeah.
when it writes back, it will be writing empty, which is resetting these fields. That case is handled.
Okay.
I'm not sure if that is sufficient to deal with the upgrade process because I don't know how the upgrade
Right.
process fully
But
works.
my question is about pods that already exist in the
Yeah.
cluster, already running. So just make sure that that case is handled. Maybe API machinery or the API review already handled this or asked you this already. I don't know.
Yeah, Jordan Leggett looked at this change and he commented that there wasn't anything to if the from the server side. When we update it, we have the new field and we set it. If it's empty, if the old pod spec is missing it, it's dropping. Essentially, the older client is writing this pod spec. Then we set this.
Right. So I guess on an upgrade now, of course, like a kubelet is not going to be like on a version higher than the API server. I believe it can be lower by 2 versions, 1 version, but it can't be higher.
Right.
And when you upgrade, I'm assuming that what happens to the resources allocated field? Do you populate it with the same value of resources to request?
Oh, we populated from the old field.
So, but if that old field doesn't exist, as Aldo mentioned, if you're coming from a version where this doesn't exist, what is the conversion criteria here? What do you set that field to?
So, okay, on upgrade, does this get, sorry to ask a question in response to a question, but on upgrade, does this become a new pod that gets created on the new API server instance?
I think probably not. It's stored in its CD. And so the question is, if we upgrade and now the schedule is running on a new binary and it's looking on that field, we want to make sure that that field is populated because right now we're taking it into account, right?
Right.
If that field wasn't set, if it is 0, then this is going to break.
Okay, let me take an item here. I'm going to look at this. Thanks for the feedback. I'll look at the upgrade scenario, really understand how it works, what happens when we do this, and I'll follow up.
Sounds good. Another question is, did you check, could init containers have this changed as well? Did you?
No, init containers, we are not allowing them to have, I think we set, we're going to set the resources allocated field, yes, but we're not allowing, they're not allowed to change.
Okay. But in the calculations, you would, I think it still makes sense to just put the code to always use the new field. It's semantically
even for the init containers. I explicitly looked at it and I didn't do that because currently it's not mutable. The requests, the existing code can continue to work because the user cannot change requests for init containers. And ephemeral containers doesn't support this field.
Okay. Yeah, I think I would prefer the code to look the same, but
okay, so 2 things. I'm going to look at making this change and first see what's happening with how does the upgrade story work when you read from etcd, what really happens.
So you, for init containers, do you set the resources allocated field to requests in the API server?
I think we're going to do that. That we're not doing it right now, but I'm going to do that because it seems safer to do it.
Okay. Yeah, just make sure that this field is actually set if we are going to make the code unified.
Yeah, we did. Initial plans were not to touch init containers, have them work exactly the same way it works today. Only the containers are affected, but it's increasingly looking like it makes sense to have this for init containers as well. so that the code is uniform everywhere, with a added validation check that if you try to mutate the resources of init containers, you're going to get validation will fail.
That's good.
Okay.
That's good. Thanks.
Thank you. Thanks for the feedback. I have to jump off. Appreciate the time. Thank you.
Thanks. The second, I lost my tab. Update.
Just want to
so-
check. Sound a little better now?
Yeah, sounds good. Okay, let's go back to this descheduler then.
Yeah, this should be quick. So what Sean has put together here is two features, like you mentioned, choosing to filter the descheduler by a namespace. Say you want to just run it for a single namespace or potentially multiple namespaces, or a second feature being by pod selector. So apply labels to certain pods, and only those pods are eligible to be descheduled. I think, and this isn't really a very new thing. People have requested it before, but I think in the past, the pushback for it was that the descheduler is more intended to focus on an entire cluster. And that's pointed out in the doc too, that there are some strategies that specifically depend on considering the entire cluster when they run. But we also have a lot of other strategies that do make sense now to just be run against a single app that might be in one namespace. Things like removing pods that are crashing consistently, or that have run for too long or violate node taints or affinity that could change. So what we have in the doc is a couple options on how to implement it. Each of these strategies, since they're so similar, they have like the same options. And those are basically a CLI option that gets passed to the descheduler, a config option in the strategy itself, or for namespaces, actually has a third one that we could consider namespace as a field selector against the pod itself. Instead of just looking at pods in a namespace, we could set this up as a field selector now, and then that might open up the road for if people want to filter pods by other field selectors down the road, which I don't know if we should be considering that one too much anymore. That was my suggestion originally. Looking back on it, I don't think that we should consider that. So it really comes down to, do we want to implement these as a CLI option to take effect over the whole descheduler and catch edge cases in strategies where we need to, or make them pod strategy parameters that can be set directly on the specific strategies that you want to run for a namespace or a pod selector. So that's what we're looking for feedback for. Sean, does that sound right? Did I cover that pretty well?
Yeah, that's correct.
Cool. So the general feedback that we're looking for is, do both of these seem like reasonable strategies for the descheduler in its current state, and how should they be implemented as a strategy specific option or as a command line option on the descheduler?
I'm not familiar with the descheduler much, but in the scheduler, having cluster level options are good to set up initially, but then you hit a lot of limitations when you want to share your cluster with several tenants or do some other kind of partitioning. So it might be good to just have it in the policy or in the pod. That's my 2 cents.
I can take a look at the doc and get feedback if I have, because I need to take a look at the doc.
Okay, so Aldo, when you said by putting it on the pod, that sounds sort of like the pod selector label option that we're talking about, right? Where it's going to be put on the pods itself, or were you referring to the strategy?
Correct. And it also, if you use the same meta types, it will be more, so it would be similar usage across different, like it would be similar to deployments or something like that, right? Or services. Does that make sense? So the API looks similar.
I'm not sure what you, so you're talking about updating the pod spec itself?
No. What I mean is if you have a policy, do you have policy CRDs, I assume?
Yeah, we have
So
a descheduler.
if you use the same like label selectors as deployments or any other workload API, and then you would have a similar API in your policies,
Okay.
which will be useful for users.
Yeah, I think that definitely makes sense. Like for label selector, using the actual label selector type that is an API. So that, I think that was all we wanted to go over for it. I don't know if there's anything else. People can read the doc and add any more comments if they have it. But I think that, you know, if we can just come to a decision on how to implement them, that both of these options seem like reasonable features. And I think it seems like people are kind of leaning towards adding it as a strategy parameter in our API.
Yeah, I can take a look at the doc and leave some comments there. All right. Alexei wants to discuss topology-aware scheduling.
Yes, hello. Swati prepared presentation, and I think she will begin with her presentation, and then I'll join.
Sure. I'll just quickly share my screen. So yeah, I think, I work for Red Hat. My name is Swati, and we want to bring this discussion about topology-aware scheduling that we've been actually having in a few other SIGs as well. We spoke about this in SIG Node. We've had conversations about this in SIG resource management. So like our intention was to bring this discussion here in SIG scheduling, level set, everyone kind of explain the problem statement, what we are trying to solve, and the conversations and the discussions we've had so far, and the way we are approaching this problem. So just present.
Sorry, full screen. Oh, yeah. Excellent.
Yep. So this is our agenda. I'm just going to go through Topology Manager, provide a quick overview what the current state of topology awareness is in scheduler, or you could call it topology unawareness in scheduler, the scheduler's view of resources at this point in time, the discussion that has happened in the community so far, a few questions and things that we'd like to chat about, and a few proposals. We have a couple of KEPs to support this proposal, and we've also had discussions about that it's a more generic problem that needs to be solved, and there might be alternative ways of doing that. So I'm going to be discussing all that. So Topology Manager was introduced as an alpha feature in Kubernetes 1.16. It graduated to beta in Kubernetes 1.18. And its primary functionality is to align CPU and peripheral devices and its allocation by NUMA node. So CPU manager and device manager implement hint provider interface, and through that they provide indication of the NUMA nodes that the device or the CPU it belongs to or it has been allocated from. So the policies that topology manager supports are non-best effort restricted single NUMA node policy. And essentially topology manager is like an admission controller, and the biggest challenge that we have currently is that in case of single NUMA node policy, it is very restrictive, and the scheduler can allow a pod to be placed on a certain node, but topology manager could reject it. So that's essentially the challenge that we have right now. So the challenge, again, the kind of risk of repeating myself, is that the scheduler is topology unaware. People who want to dig deeper into the issue itself, they can, I have a link on the slides, they can go dig deeper into it. But the main problem is that in case you're running topology manager with a single NUMA node policy, guaranteed pods, if they request more than resources more than a single NUMA node, but less than a whole node, it causes runaway pod creation. And the reason is because scheduler has a different view of resources. So in my next slide, I'm going to explain this with the help of a diagram. I'll just continue this for the time being. The scheduler will basically send the pod on the node, and topology manager will kind of reject it, and that would lead to topology affinity error. If the pod is part of, say, a deployment or a replica set, that would continue to happen because it would continue to suffer the same fate. So this is an example that I want to explain. In this case, we have like a 2-node cluster. From scheduler's point of view, we see that both the nodes have 3 instances of device A and 3 instances of device B. It doesn't have visibility on what NUMA nodes they are on. And that's the reason this problem happens. So if a pod like this comes up where you're requesting an instance of a device A and 2 instances of device B, the scheduler could think that, okay, master node is suitable to place that pod. When it does that, everything works fine because topology manager understands that, okay, we with the single NUMA node policy enabled, we can place it on NUMA node 0. But the problem happens when the scheduler decides to place it on, say, this node, where the topology alignment is not possible and topology affinity error happens because topology manager rejects the pod. So we've had kind of a bit of a discussion on this topic. The slide is to kind of level set on that. I'll hand over to Alexei to talk about the discussion we've had so far on this topic. Alexei?
Sorry, I was mute. Yes, there were a lot of discussion in SIG-Node meeting and in SIG-Node resource management meeting. The first one was much before than April. Here I mentioned April discussion about the topology manager and NUMA-aware scheduling, and then in May was discussion about NUMA-aware scheduling. We narrowed the possible approaches, reduced the number of approaches, and we research following approaches. Come out kubelet from a scheduler. It's just a call of kubelet endpoint from scheduler plugin. So this approach was rejected. Also, we tried to move whole topology manager and its dependent manager like CPU manager and device plugin manager into counterplane, into separate daemon, but this approach also was rejected. So we stayed on scheduler plugin-based approach with CRD object for exposing NUMA information. frankly saying, this approach with simplified topology manager was suggested by Wei Huan on SIG-Node meeting, as I remember. So we decided to follow this approach because it has the minimum number of known to us drawbacks. So the main part of this approach is gathering resource topology information. We prepared an enhancement proposal. You can find it here, and we published it. Currently, we exposing resources with CRD format, which describe it in document custom resource definition standard for node resource topology. We also tried and investigated another approach like extended basic structures, for example, node structures and its allocatable resources, and also place resources into annotation. But SRD looks like a better approach. Currently, we have a daemon, and we already have an implemented kubescaler plugin. So I think we can move to the next slide.
Yep.
Oh yes, here you can see example of CRD instance. It contains of topology policy, because it's important to know which topology policy on the work or not. And the list of nodes with node ID and list of resources of the NUMA node.
Yeah, so usually in this case, we'd be creating a CRD instance per node. So the scheduler can refer to that at the time it's making the scheduling decision. So, so if for a multi-node cluster, you'd have multiple instances created for scheduler to refer to.
Can we ask questions now, or do you want to ask questions at the end? Oh,
yeah,
okay.
yeah, for sure. Yeah, Go ahead.
That's a good question.
So if you go one, like you're talking about the CRD, and the CRD will basically be describing the NUMA architecture of the node, right?
Yeah.
And how much resources is there on each NUMA node. Like you mentioned that you discussed having this information in the node object itself. What was the outcome of that discussion? Why was it rejected? Why do we need a new object to represent the data or properties of the node while we have a canonical node object or type?
I think the objection currently to that is that we don't want to introduce too much topological information into mainstream Kubernetes objects. That's the main reason we are going ahead with the CRD-based implementation. So yeah, so that's the feedback that we got. Like introducing it into like main node object probably is not reasonable.
And as I remember, the discussion initially started at November last year, and the result of the discussion was that it's not necessary to provide additional topology information. It's better to hide it somehow from users, from operators, from administrators, and so on.
Yeah, in this case, it gives us the ability to not provide NUMA information in the pod spec itself, and it would like intrinsically try to do it based on the topology manager policy and based on the mechanism that already exists within Kubernetes. That like Alexei said, that is definitely one of the motivations for doing it this way as well.
Right. I mean, we do have
Another reason
precedence here, with the CSI node. So it did initially was introduced as a CRD, and then now it's a like
Yeah.
an upstream type. So I get that, but I just wanted to hear like why the like SIG node. It makes sense to me. And my question is this CRD going to be? Is this like just the first step? Are you have it like
Yes,
as a
it's
first type?
yes, it's definitely a first step because right now not all clusters, not all worker nodes have NUMA in its hardware.
Okay. And who's going to maintain this CRD? This is my last question, then I'll open it to others.
Yeah, so actually that is part of one of our asks as well. So the way we see it is that it should be at a neutral sort of position, and we wanted to ask if maybe Kubernetes SIG is a reasonable place to place that. Like that's something that we wanted to chat about as well. What would be a reasonable place where we can
Right.
like
There are
I
two
think
things.
we're happy to maintain this piece of code and gather feedback on that, but it's a matter of where do we like place it.
So there are two things. There is the plugin itself, which I think it's fine to have it in the scheduler repo, the same way we did with the CSI. Again, as long as there's a buy-in from multiple SIGs in Kubernetes. But the CRD type itself, and who's going to maintain that CRD, you know, like the type, I don't know if there's any functionalities around it, like utility functions, etc. I feel that it belongs to the node more than the scheduler. Again, like
Yes.
we can take lessons from the CSI experience, and I'll just leave it at that and see if anyone else has any questions. Or
Abdullah, one moment. You mentioned CSI because CSI is listening for CRD, right?
at some point, yeah, at the initial implementation, they introduced two types. One of them is actually extremely similar to what you want to do, which is the CSI node, and it has like node level information related to the storage.
Okay, I have seen implementation of CSI plugin, and I also introduced CRD informer inside plugin.
Right, I'm talking about the CRD definition itself, like
Oh yes,
whatever definition functions around it. Yeah, this is a different thing, right? Like from saying, okay, I'm going to implement a filter in this scheduler that takes that into account.
Yes, CRD type, also maybe client set and informer. And,
yeah, everything around that. I think it, yeah.
Yeah, we need to find a place where we can keep it.
So now that you're mentioning CSI, would you like to, do you know where did they do it? Where did they place code corresponding to some?
So basically, CSI has a separate GitHub repo, and initially I think they put their definition, CRD definition there, and then at some beta or some space, they moved it back to Intri. So I think the Kubernetes SIG is a proper place to place the initial definition of the CRD.
Okay.
Okay. The question now is, can we request for new repository in Kubernetes? Because now we are keeping our code in private, in our repositories.
Yeah, I think so. Yeah, a subrepo isn't a big thing. You can just use the, I think, Kubernetes/org, use that repo to create an issue, and there is an issue template. You can say you want to create a subrepo, and before that, you better negotiate with SIG-Node. I think I agree with Abdullah that SIG-Node seems is a better place to own the CRD. So needs kind of down-chain or direct cross approval on creating that subrepo, then you can create that issue.
So thank you. Thank you. I hope we will find the template.
Yeah, we will. I think we'll get in touch with them and we'll try to see what they see is the right way of going about it, and then hopefully we'll create a SIG repo. Any other questions and comments on the presentation or?
Alexei, if you can go one slide back to your CRD object. One thing which I haven't noticed in initial review, but triggers my question right now. So you have in this example information, what like in NUMA 0, you have vendor NIC 1, and on NUMA 1, you have another vendor NIC 1. So how you are going to get that information?
Oh, we have already implementation, Swati did it. Also, we have two possible data sources, and the first one is CRI interface, but this topology information not in the. Yes, you're right. Container D implements it as additional information in the info field. Yes, it's not in CRI interface. It's implementation dependent. And
Yeah,
the
so
second,
as part of the container runtime response, there's an info field, which is again a free-form field, and container D uses that to populate the Linux container runtime resources information.
yes, and the second source. Speak, please.
So this label, what you are saying, it's known only for device plugins. So this information is available only inside the kubelet and device plugin. So I'm really curious how you're getting it.
Yes, the second data source, it's a port resource interface of the kubelet. It provides resources which was initially provided by device plugins, but currently this interface doesn't provide CPU. So we discussed it with David, who was initial author of port resources, and he agreed to extend this interface to provide also the CPU.
But does it really provide all enough mappings saying like what device plugins is reporting for topology info?
Yes, no more information also there.
For non-allocated devices.
For non-allocated, what do you mean by non-allocated devices? Which not yet allocated?
Well, if I remember correctly, the API for Node, for pod resources, it shows like which device ID allocated to which particular pod. But I don't remember what reports unallocated devices.
Yes, we will take into account kube reserved and system reserved and the whole system resources. And
no, I'm talking about the devices which are coming from device plugins, like not reserved, not system. I'm specifically talking about like this vendor / NIC 1.
So I think the way device plugins currently work, especially like if you consider SROV device plugin, the device ID usually is used to populate the PCI address, and if that is used, you could evaluate the NUMA node on which the device exists. So that information could be gathered from there, and so
it's
I think
assumption for one particular device plugin, not all the plugins doing the same.
Yes,
yes,
right. It's not a problem to put NUMA ID, but as I remember, we were able to evaluate NUMA from device ID, and currently it's not a problem.
So we are 15 minutes, almost 17 minutes over the time. If we can move that discussion into the CAP, I guess that would be one option, or we can open that discussion again in the next meeting. But I would like to open the floor for others to ask questions about this before we end the meeting.
I have one. Just on the, you said there was an agreement to include the CPU information in the pod resource endpoint. Is there a KEP for that? Is there information on how that's going to be implemented?
No, we
Not
didn't
yet.
prepare a cap for pod resources, but we are going to do it.
Yeah, just before we end, I just want to bring this thing as well, which we had brought up in one of the the PR discussions. So like I mentioned, that there's probably a more generic problem to solve here, that scheduler proposes and indicates that a node is suitable, but the kubelet on that node rejects it. So we had kind of provided, or it was a really nice idea about how can a scheduler actually propose more than one nodes to be nominated for a pod to be scheduled on. So that is so we have, as part in the slide deck as well, we have a link to a presentation which discusses this in more detail. We can probably come in one of the next SIG meetings to talk about that as well.
It would be nice if you can share the presentation of the SIG mailing list, if you don't mind.
Sure, yeah.
Like this one, so that we have links and then like we can review it.
Yeah, I'll do that. I'll send a link to this presentation and the other one as well.
Okay, thank you. Any other questions?
It's not a question, it's more regarding the comment what Swati just mentioned, this issue. So it's not only about admitting the pod, it's about any kind of error situation which happens between the pod is arrived to the kubelet and actually started. So like the error condition can happen because some of the admission hooks is failed. It might be some storage attachment fails. It can be like runtime related creation errors. So practically to get to a state what we sure what we can run the pod on the node, it's practically all those steps needs to happen. And only the last operation like start container can be already treated as separate error.
Yeah, yeah, and the other thing actually I want to add here is that if we go ahead with this proposal as well, it would improve the chance of a pod to be successfully placed, but there could be a scenario that topology affinity error would still occur because no node is able to fulfill that that pod. And again, having that visibility at a scheduler level to decide that the pod is not schedulable, so you probably just need to keep it in a pending state till a suitable node arrives. I think that's the state, or that's what we are hoping to achieve with this proposal. So yeah, there are a lot of things to be covered here, and we'll be taking actions on all those.
Okay. Yeah, in general, I like the approach of having the topology described in the CRD. It's a K8s native way, I guess. That's one way to put it. And hopefully we can make progress in that direction. So as a SIG, I would say, like, I don't know if anyone has any objections. It seems like something that makes sense. So, but there's the KEP there. If anyone has any concerns, please bring them up on the KEP.
Yep.
Right. Thank you so much.
Everyone.
Thank you.
Have a good long weekend.
You too. Bye.
Thank you.